Hi, Michael Wolf, PGI compiler engineer. Here we're talking about the deep copy problem. The deep copy problem occurs when you have a struct or array of struct, and each element of that struct or Fortran-derived type has a pointer to another dynamically allocated array. So now I need to move the whole data structure over from the system memory to the device memory and back. That's the deep copy problem. In our last video, we saw that you can use managed memory to address this problem rather simply, but you might want to have more control over the data or to explicitly move the data rather than managed memory, which is reactive. It moves the data on demand. If you want to do asynchronous updates from host to device, for instance, managed memory is not going to solve that problem for you. In our last video, we also saw that the PGI compiler supports explicit or manual deep copy. Today we're going to show you a new feature in the PGI 17.7 compilers, implicit deep copy, which works for the Fortran arrays of derived type. So I'm looking at my Fortran artificial example, and I have two derived types. I have a garden, an array of gardens, and in each garden I have an array of plants. This is to describe my own backyard. In each plant I got information about the kind and the color and the height and so forth. And inside here I have a routine that's going to count how many plants of each kind and count how many plants of each color and then print that out. So I need to move the data over to the device and bring it back. In the upper case, I'm using manual deep copy. So I have an enter data copy in for the base array, and then I have a loop around an enter data copy in for each subarray that each element points to, and similarly for the copy out at the end. What I'd like to do is to simplify this as much as possible. So I'm going to build this uppercase, and you will see here it does the enter data of the garden and the garden % plant, and then there's a couple of static arrays that get explicitly copied back and forth, which we saw also in our last video. I'm going to run this program with the PGI ACC notify environment variable set, which will show each data transfer and show each kernel launch. And so here it's showing the upload of all the data and each element of the array, and then eventually the kernel launch, and then downloading the data. You'll notice in here when it's downloading the data, there are also some uploads. These uploads are resetting the pointers on the device of the base array so that when I move the base array back to the host, the pointers will be reset back to their host values. So that's fine, the program works, but I had to insert this subroutine to manage the data transfers from the host to the device and back. What if I could get rid of that? So what we have in the lower case is almost the same program. When I skip down to the routine that copies data to the device, I only have the copy in for the base array because I'm using implicit deep copy. In the implicit deep copy, the compiler in the runtime will inspect the data structure, and if it has a submember that is itself a dynamically allocated array, then it will go ahead and copy that subarray over and look recursively in that subarray for dynamically allocated members. And what we see here is it simplifies the programming aspect, although the execution is going to behave more or less exactly the same as the explicit or the manual deep copy. I enable the implicit deep copy with the t equals Tesla. I add my compute capability and the deep copy flag. I'll set the environment variable again to notify us of all the data transfers. This is the upload here of the descriptor for the array and the garden array. And then here is the pointer and descriptor of the plant subarray for the first member and the plant subarray for the second member and the third member and so on down to the very end. And eventually launches the kernel, and then downloads the data for each of the array members. So the implicit deep copy option will copy all the submembers. If you want to transfer just some of the members, or to transfer some members in one direction but not bring the data back and optimize data transfers, then today you'll have to use the manual deep copy. Notice this is only for dynamically allocated members. Obviously the static members get transferred when you transfer the original array. We think this will simplify life for Fortran programmers that need the deep copy option. For C and for C++, this feature is not available because C and C++ pointers have no size information. The compiler and the runtime don't know the size of the allocated data. In Fortran, we have descriptors for those arrays, so the runtime can determine the size of the allocated data. But our next video is going to show where the OpenACC specification is going in order to solve this problem in a more general and descriptive and powerful fashion for users.